GNSS, Global Navigation Satellite System. What does GPS provide? Instant horizontal position to an accuracy of 3 to 10 meter, 95% of the time is easy. Instant position to an accuracy of 1 to 2 meter, differential GPS, relatively easy setup cost based on code pseudo ranges. Processed position to an accuracy of a few centimeter, instant position to an accuracy of few centimeter, mainly by phase pseudo ranges. Post process position to an accuracy of a few millimeter over a few kilometer. Post processed position to an accuracy of few millimeter over a few hundred kilometers, which is very hard, mainly by phase pseudo ranges. Advantages of satellite navigations are all weather, works in rain, cloud, sun, snow, any space weather, etc. It provides coordinates on a global system, 24 hours capability, worldwide availability, no subscription fee, no line of sight needed between terrestrial point. So GPS involves 5 basic steps: trilateration, SB ranging, timing, positioning, correction of error. So accurate timing is the key. SP have highly accurate atomic clock. Receiver have less accurate clock. Measurement made using nanosecond. 1 by 100th of a second error could introduce errors of 1860 mile. Discrepancy between satellite and receiver clocks must be resolved. For the satellite is required to solve the 4 unknowns. Satellite positioning also required in the equation to solve the 4 unknowns is the actual location of the satellite, SP, or in a relatively stable orbit and constantly monitored on the ground. SP position is broadcast in the ephemeris data streamed down to receiver. So how does GPS work? By satellite ranging, distance measurement, low tech simulation. Satellite ranging is nothing but location, user distance from satellite. Need for satellite to determine position. Distance measurement or nothing but radio signal traveling at speed of light. Measure time from satellite to user. Pseudo random code, a complex signal unique to each satellite. All satellites use same frequency, amplified by information theory and economical. So signal structures. Each satellite transmits its own unique code. Two frequency used, L1 and L2 carrier frequency. So CA code is used in L1. In L1, L2 we use P of Y code. So range from each satellite will be calculated by time delay into speed of light. Technique called trilateration is used to determine the position or fix it. At least 3 satellites required for 2D fix. However, 4 satellites should always be used. The fourth satellite used to compensate for inaccurate clock in GPS receiver, which yield much better accuracy and provide 3D fix. So distance to a satellite is determined by measuring how long a radio signal takes to reach us from that satellite. To make the measurement, we assume that both the satellite and our receiver are generating the same pseudo-random code at exactly the same time. By comparing how late the satellite's pseudo-random code appears compared to our receiver's code, we determine how long it took to reach us. Multiply that travel time by the speed of light, and you have got distance. High-tech simulation. Accurate timing is the key to measuring distance to satellite. Satellites are accurate because they have 4 atomic clock on board. Receiver clocks don't have to be too accurate because an extra satellite range measurement can remove error. To use the satellite as reference for range measurement, we need to exactly where they are. GPS satellites are so high up their orbits are very predictable. All GPS receivers have an almanac programmed into their computer that tells them where in the sky each satellite is moment by moment. Minor variation in their orbit are measured by the Department of Defense. The error information is sent to the satellite to be transmitted along with the timing signal. This is the position which is based on the time. So signal leaves the satellite at time t. Signal is picked up by the receiver at time t plus 3. So distance between satellite and receiver equal to 3 times the speed of light. This is the pseudo random noise code. This is what time is it? It's calculated by universal quadrilateral timing, Greenwich Mean Time, GPS time, and Zulu time. This is signal from one satellite where the receiver is somewhere on this sphere. So signals from the two satellite. So 2D position of the three satellite, triangulating correct position of the two satellite, three-dimensional positioning of the satellite, four satellite. This is the GPS position determination. Next is system performance. So standard positioning system have 100-meter horizontal accuracy, 156-meter vertical accuracy, designed for civilian use, no user fee or restriction. So the precise positioning system have 22-meter horizontal accuracy, 27.7-meter vertical accuracy, designed for military use purpose. So the system performance under selective availability or intentional degradation of signal controls the availability of system's full capability. Set to 0 May 2000. Reason: enhanced 911 service, core navigation, adoption of GPS, time standard recreation. The Earth's ionosphere and atmosphere cause delay in the GPS signal that translate into position error. Some error can be factored out using mathematics and modeling. The configuration of the satellite in the sky can magnify other error. Differential GPS can reduce the error.